Okay. So now I think you can all see. So here's Tane's question. In R, there's a feature that allows you to pipe functions using this operator. And is there an equivalent in Python? So Tane, can you if you want to come off of mute, what's this operator called in R? I'm not familiar with it before now. Just what do they call it?
Let me see. What do they call it?
Like composition or it's not really composition exactly. It's more like
It's like the pipe operator.
the what?
The pipe,
The type operator?
pipe,
Oh,
like
pipe.
piping.
Oh, they call it pipe. So it's
Yeah, it's a built-in like
essentially
operator in R. Yeah,
so it's something like this. What
yeah,
I
yeah,
just wrote
exactly.
here
Yep,
functionally,
yep.
that's okay, okay. Let me think about that. Is there something like so you'd have in Python, if Python had that, you'd have func. Um, when you write it in R, is it like which is the inner function first or is the outer function for written first?
It's like sequential. It's like inner. Yeah, it's like you do a func one, and then whatever output of func one is pipe the func two.
Uh-huh.
Yeah. But I don't know. Yeah, it's just I think just from a visual, from a visual standpoint, when I
Mhm.
have like five or six different function, I
Yeah.
like, and it's just like adding new things to the data frame or like running new things. I started like running out of like good names. So
Yeah.
usually I may just do like something like df, and I just like
Yeah.
override, uh, like
Mhm.
many times, instead of.
That's typically the idiom that people use, even though I don't love that. Like, so what just sort of what he's saying is what Tane is saying is that people will do, df equals get df. You have some way to get it originally, and then you just read
Yeah, exactly.
excuse me,
Yeah.
the variable name. So like this, talking about this idiom in Python, right?
Yeah, and maybe in the end I have like a final DF or something. Yeah. Or like I
Yeah,
call it like a
final.
new DF or something like that. Yeah.
Yeah, yeah. Or even, just that is another
Yeah,
thing
or just
to do.
that. Yeah,
I'm
exactly.
not
Yeah.
advocating that, but it's something people do. Yeah. So, but what we're really thinking of, so when you write it in R, if you were to literate it as literally as possible into Python, I just want to check, is it something quite close to what I have highlighted here?
Oh, in R? You mean in R?
Yeah, if you took the R, like it's an R syntax, and then you translated it into Python as literally as possible at this syntactic level, would it look something like what I've highlighted here?
Yeah, yeah, maybe I can do like a df dot pipe and then func one and then dot pipe func two, and then with some like positional arguments, like
Oh
which would
yeah.
stand for the arguments within the function. Like that would be something I think would be very nice. And then maybe fun one take some argument like yeah, like a or b, and then you can just like
Hmm.
fun one comma a, and that a would be like a like yeah. And I think
Let me think about
like
this.
df dot pipe is a real thing. Actually, it does that. But I wasn't always working with like data frame, so
Well,
that's why I wanted
yeah, that's
to, yeah.
specific. If Pandas data frames has something that will work like I just wrote, then that's specific to data frames. We're really asking about a more general feature here. Um, I'm wondering if there's some way to. Now you got my brain working. So let me think about this a little bit. So, Python.org. Maybe I'll screen share that too. So
Yeah, and
um, let me Um, I think it's oh, okay, maybe. So what I'm doing is I'm looking up the magic method for the pipe operation because there is, you can say in Python X equals A or B. That's a bitwise or. Um, okay, yeah, it's just under or. Okay. So I wonder, there's not a general facility. Now, what I'm thinking though is it might be, so there's no general feature of Python that will work in this way. Okay. There's no way to kind of not compose them but chain them. I'm not even sure what the correct vocabulary is, but you basically have a binary operator that takes a callable, the two callables, invokes in that, and this binary operation returns another callable which will take one or more arguments. So let's see if we can even write this. I'm wondering, we don't need to share the let's see, if we say class chained func def all. So then let's just do it with one argument to keep it simple. Oh, I got an idea. Then if we did maybe def or um so what are we going to do with that? New func equals, let's see. Let's see. No, def new func. Return self dot other, let's call this other func. Let's combined. It's called, oh, chained, even better. Okay, other func and then self dot func. Okay. Um, I'm going to be flabbergasted if this actually works. Everybody understand this is a mad science experiment you're witnessing right now. So let's see if it actually works well. So let's see, def f of x return x plus 2, and then def g of x return x plus, well, let's make it y. Just keep y plus times 2, okay? And then print, and then we have f or g called with the argument 1. Okay. Say results is this. Okay, so let me pause before I run this and let's see what it actually does. So if I did this right, then it's going to apply f with the argument 1, and that'll return 3, and then it'll be applied to g, which will return 3 times 2 equals 6, so it'll print that, right? So let's see, Python 3, demo 3.py. Okay, what did I do wrong? Let's see. Oh, I see what I did wrong. Who can tell me what I did wrong?
Did you use the pipe instead of the or keyword?
No, that's not what went wrong. So the pipe operator corresponds to dunder or. And by the way, I saw your comment, Jim, the map function. Let's return to that. Off the top of my head, I don't think so, but maybe you're seeing something I didn't see around that. But let's complete with this first. The thing I did wrong was I'm passing bare functions when it should be there should be a chain function. So really what we should do is decorate this. And I think if we do that, then it works. Oh, wow. That is the weirdest freaking code I've ever written, I think, maybe. Wow. Okay, so let me translate. Okay, raise your hand if you're baffled. You don't have to raise your hand. I know you're all like, this is very strange code. Okay. So what happens is we've okay, so there's kind of a lot going on here. Remember that first of all, this is actually correct. Okay. Everybody understand this? Like, we're saying this is the thing we want to create. So we say G, we're applying F first to the argument one, and whatever's the result, we pass that to G. So this is actually the output. It prints out 6. That's actually correct. Okay. But let me explain how and why. Okay. So first of all, remember the definition of a decorator is that it's just, it's a remember we're kind of going from the first principles here because this is a example of a decorator that you've is not ever been documented anywhere I've ever seen, including in my own book or my next level Python course. Okay, because in the course in the book, I teach you how to create implement a decorator as a class, but there you take the bare function in the constructor just like here. But what you don't do, what I'm doing here with dunder call is I'm actually just calling the bare function. I'm not creating a wrapper, right? So this is a different decorator pattern. This is a novel. We've just invented a new decorator pattern here. Okay. So this is what we're doing here is we're creating. Remember that this is a shortcut for this. Def F. And then I'm not going to redefine it because I don't want it to overwrite what my previous definition. But then we define def. Actually, we can just then we say F equals chain func F. Remember, this is a definition. So those of you who have not gotten to next level Python yet, this is, I don't know how to succinctly, okay, those of you who have not been in next level Python yet, you're not going to understand this yet through no fault of your own because it's leveraging some very advanced meta programming concepts that you will learn when you get to the next level Python course. Okay. I just want to clarify that for everybody. But what you're doing here is you have this chain function, decorator is applied. And when we type this, it's a shortcut for this. Okay. So we define a function called F, and then we execute this line. And this line is fascinating because the symbol F is different on either side. That's not what's too weird. What's more weird is that its type is completely different because on the right-hand side, the type of F is function. I'm sorry. Yeah, the right is what I meant to say. I think I said left. On the right-hand side, the type of F is function. And on the left, the type of F is chained func. It's an instance of the class called chain func. So we're not just overwriting the value of this variable that contains a function object F. We're not just changing its value. We're changing its type in a radically different way. And its only relation is that they are both callable. This instance of the class called F here on the left side, and this instance of this function object on the right, they both have dunder call methods. They're both callable because Python function objects have a dunder call method. That's how they're calling. That's how that is done. Okay, so that's what we're doing here. And the interesting thing is that we don't have to do it for both of them. But if we do, it's fine. Okay, we can, but we don't have to. Okay, because what this, when we say like combined or chained, that's the exact same thing as saying equals f dot dunder or g. Okay. As far as the Python interpreter is concerned, it literally cannot tell the difference between these two lines. They are saying the exact same thing in the exact same way. Python, so when we write this, that's a shorthand for a method call as far as Python is concerned. Okay. So what we're doing is when we create this, right, when we type this expression, what I've done is I have in parentheses this f pipe g that translates into a method called dunder or, which returns chained func. So what's being executed here, right? This whole expression is chained func. And that's what's being executed. And there's a closure, which means a reference to the enclosing scope, where you have other func is passed in as a local, as an argument to this method call. And then it references self.func, which is defined in that scope. And this function object called chained func, when it is it retains its closure of the scope in which it was defined. That's why self.func continues to be defined. And what we return is an instance of the chained func class. So the instance of chained here, it's not a function, it's not a function object, it's an instance of the callable chained func class. Questions?
I have a quick question.
Yeah, go ahead, Brad.
Is it generally desirable to, I mean, if I'm understanding this correctly, and I'm not confident that I am, you essentially overwrote one of the dunder methods for or.
Yeah, well, we've defined, it's not really overwrote. What we're doing is using it in a way differently from, well, first of all,
Or well, let me back up and ask maybe a better question then.
yeah.
What are the likely ramifications for having done this? Is it basically are the ways that dunder or get interpreted limited only to when you're using that chain func decorator?
Yeah, well, it's limited to whenever we're using the binary pipe operator like this. So anytime we type F and then a pipe character and then G, or at least the thing on the left is an instance of chain func, then this will apply.
Okay,
And
but
it
if
won't
you
be apply in any other context.
all right, but let's say somewhere else in a code base you have you're using the pipe operator just as the standard kind of or. You want to
On an
accept
instance of chain func? Because okay, I see what you're asking now. It wouldn't affect any other usage. Only if the thing on the left-hand side is an instance of chain func. So if it's an instance of anything else, it will not trigger this method call. It'll
got it.
just
Okay. So that's how you limit this from breaking anything else.
Yeah. It doesn't propagate to all of the, it's because it happens at the level of the basically the type of the operand, the leftmost operand, but it does not, to break it, it would break it if it was applied at the level of the operator itself. And some programming languages let you do things like that, but it's not how Python works. And so in this case, it won't do anything. It won't even, F is of a type anything other than chained func or a subclass of it, then this will not get triggered at all.
Got it. Okay, that's what I wanted clarification on.
Yeah. So Tane, talk to me. How does this fit in with what you're thinking about?
No, yeah, this is perfect. The question I have is there a way, say, maybe I want to create this chain func, but is there a way I could do this? I guess I could maybe just do a chain func. Um, I created like just the fx return x first, for example, because like say, if in this format, like if I do g pipe x, like it doesn't work, right? It's only work
What?
if I do g pipe f, it doesn't work. I have to do f.
Actually, I think it would because we've decorated both of them with chained funk.
Oh, okay, I see. Yeah,
Yeah.
okay, that's
If I
fine. Yeah,
decorated, I think what you're getting at is if I had like originally, it's not what I did, right? Originally, I
yeah,
decorated F, but
yeah,
not G, and I think that's what you're thinking of. And in
yeah,
that case,
yeah.
I think let me double check. But I think that let's see. Let me just G type F, and I commented out this decorator. So let me, yeah, okay. Yeah, it won't. G is not defined. I wasn't expecting that. Hold on.
Oh, maybe because you have the chain equal
Oh,
F and
that's
G in the
yeah,
middle. Yeah.
that's one. Yeah. Okay. Yeah. So that did not work because it's an unsupported operand type for the pipe operation. But if I uncomment this, I think it'll work now. Yes. Okay. Yeah.
Oh, okay. Okay. Yeah.
But
Yeah.
yeah,
Okay.
you
That's
totally
fine. Yeah. Yeah.
like the your question tells me you understand this completely. Your is the right question, that you understood, where the source of this new behavior comes from. Now the question is, should you even do this at all? Might not be worth it, right? It's first of all, if you have data frames, it's something you can do. And by the way, you could apply this to a method as well as a function. There's nothing specific to that. What I've defined here. But what you can do is, you can apply this to a function or method that you're defining. But if you're using a library's methods or methods of a class it has or functions,
Mm.
you know, technically you could kind of monkey patch in a decoration, but it's not often done. It can lead to code that's a little hard to maintain and extremely surprising for anybody else using the code base.
Mm.
So I kind of don't recommend it, generally speaking. So it's possible to do this in Python, but it's not necessarily something I advocate unless you're doing it with code you've written from scratch. And that's um kind of an interesting scenario here. So,
Mm.
yeah, it's interesting. I'm really glad you asked this question because this is a new decorator pattern that I've never seen before. I think we just invented it here.
So actually, I think this one maybe the better using, like, instead of using the pipe, should use like the and symbol. So if for the and symbol, you just switch an or to an and would that work?
Well, the thing about this is like it doesn't matter. You could use any magic method corresponding to any binary operator that's available.
Yeah.
Heck, use plus if you want.
Mm.
But the thing is like some libraries will hide. So okay, so notice that in if you have like a data frame, for example. Okay, so import pandas as PD, and then you have, PD or df equals pd dot read CSV. something.csv, okay? And then what you do, imagine that what you do is you say like let's say positive net worth, or let's say high net worth, DF equals DF. Let's see, let's say just DF2. I don't even know trying to make it realistic, but let's say DF and then square brackets DF dot A greater than 10. Let's just make it abstract, okay? And then DF dot B less than 2, okay? So how does this even work in pandas? This is valid pandas, okay? What you're doing is you've loaded in a data frame, and then we've created a new data frame with a subset of rows that were in the original source data frame, basically keeping only those where the value in the A column is greater than 10 and the value in the B column is less than 2, right? So we say and here, indicating that both those criteria must be true. Or we could use the pipe character, which in this case suggests the concept of Boolean or, meaning if this is true or this is true. Okay, so how does this even work? Because this is not even valid Python. I mean, if you go by, just logical, because notice that we can't say or. So we're distinguishing between bitwise or, which is what the pipe character does with normal Python numbers, versus logical or, right? Which is a binary operator that takes two Boolean values and returns a Boolean value, right? Logical or, okay? So it turns out there's no magic method for logical or, neither is there a magic method available for logical and. The reason for that is because Python does short circuiting in Boolean operations. And there's just not a way to make that work along with magic methods that can override it. Okay, so there's special behavior baked into the the Boolean and the Boolean or operators that preclude using magic methods for it. Okay, so, or at least no one's figured out how to make it work in a sane way yet. I'll say that way. Maybe someday we'll have it, but I've thought about it really hard. I was going to write a PEP, and it turned out to be really, really hard. So I abandoned that. I'm sure many other people have tried it too. But so what you'll find in situations like this where people, authors of a library want to write give you something like a logical and behavior, is they will hijack the bitwise and operator, and likewise for the bitwise versus logical or operator, because you can write a magic method for this and behavior, right? It's just and. Okay, that's the bitwise or the bitwise and magic method. Okay. So there's some expression basically that if the way you do this is you say, okay, data frame, DF is a data frame. It has an attribute which is labeled, corresponding to each label of the row. Okay, so if you define it with rows A, B, C, and D, it will have 4 attributes, capital A, B, C, and D, and you use the dunder get attr magic method to detect when you're referencing one of those. And if it's referencing, something that's not a row, you throw some kind of access error, attribute error. But if it is, then you return an instance of some class that represents a column in the data frame. So what I've highlighted here evaluates to an instance of that column class. Okay, whatever it's called. Pandas doesn't call it column. I forgot what they call it, but basically it represents a column in the data frame. And that column class has a dunder GT method, okay, which is the magic method corresponding to the greater than operation, which traditionally should return either true or false, but that's not what this expression returns. What this expression returns is some other object that represents a comparison, and that comparison class, instances of that comparison class, have a dunder and magic method. This is how pandas actually works. If you dig into the source code, this is how you'll find out how it actually works, which is pretty freaking cool if you ask me. I think it's just amazing. You'll notice that they put parentheses around these. The reason is that the bitwise and operator and the bitwise or operator, they have different binding priority than logical and. They have a higher binding priority than logical and or logical or would. So if you did not put in parentheses, it would evaluate like this, which was just not useful, right? It's a completely different ballgame. So that's why when you see libraries hijacking the bitwise and or operators to do something like logical and logical or, you will have to put in parentheses around the arguments to the binary operator here. That's why you have to do that, because it has different type precedents, or different precedents of operator precedents is what I mean to say. Okay. So I feel like I diverged a little. I don't recall exactly what was the question you asked, Tane, that put me on this.
Oh yeah, I was just saying that like when I pipe my functions, maybe instead of using the or, like I could use the and operator and
Yeah,
and my
you could. I mean, as long as you're consistent, it doesn't matter. And as long as it's, unfortunately, you cannot define a new custom operator. That would rock. Scala lets you do that, but not Python. So if you want to switch to Scala, then you can do that. But yeah, so yeah, you have to use the built-in ones. That's one of the things I like about Scala, by the way. I was really into that for a little bit when I was teaching Spark for Databricks, because originally Databricks platform was implemented in Scala, so you could do more with it if you wrote Scala code instead of Python. And one of the fun things about Scala is you can literally create you could create an operator that like looks like this. That's a valid operator in Scala if you want to define it. But Python doesn't let you do that, and the world is probably a better place because Python doesn't let you do that. In any event, how well does this answer what you're asking about, Teen? So Python doesn't. What would be great is if Python had something like this just baked into the language that just worked for any callable, even if you didn't take any special action to make it work. And unfortunately, fortunately or not fortunately, Python does not support that. And so, but this is the closest thing we can come up with in Python.
Yeah, this is great. Yeah, thank you for showing me this.
Yeah, you're welcome. Thanks for the question. I'm excited that we discovered a new decorator idiom to get pattern together, everybody. Seriously, I don't think I've ever seen this anywhere or in any code base. I think this is actually genuinely new. Okay. So Jim, let's go back to your comment that you typed a long time ago here. Wouldn't the map function work? Let me think about this. I don't see how. Do you see how, Jim, you could use the map function to implement something like, again, remember, this is what we want to do. Do you see how you could use map to do something like this? I'm not seeing it.
Well, at first I thought about that because I was thinking, well, map allows you to abstract the execution, but you have to define a function with the parameter up front. So unless you
the thing is, map applies a callable to a collection. You know what I mean?
Yeah.
So it's not really doing the kind of thing we're talking about. And I can't think of a way to use or abuse map to do something like what we're doing here.
Unless you were to create a decorator that would call where the collection actually has a list of functions that you want to reference, and then have the decorator interrogate each instance
yeah, but that
of
would
the
be
collection.
totally different from what map is doing, right? It would be a totally new thing. That's not saying the thing might not be useful, but that would be a generalization of this, right?
Right.
You could create this new thing. I don't even know what you would call it, but it would generalize this to two or more. Well, to one or I guess you could generalize it to zero or more operands. Where if zero, it's just the identity function. yeah, but you could generalize this to not equal to, not exactly two callable arguments using that approach.
Yeah. One thing that did pop into my mind just out of the blue when I was looking at this and when I commented, wow, I I remember in the boot camp when you introduced the pub sub pattern.
Mm-hmm.
I was thinking, wow, this almost reminds me of the pub sub pattern where but instead of explicitly subscribing to a message, all you're doing is just the parent could be Funk 1, and then all the children could be Funk 2, 3, 4, and 5, where they're all getting called. But unlike the pub sub method, this would not be as flexible, but it's still very interesting. This is a big wow.
Yeah, I mean, one thing I really like about this is it's just kind of eye-opening to the other dimensions that Python has that we can leverage. Like look
Yeah.
at this conversation we're having right now, right? It's very stimulating. So